For this video, we'll be talking about inheritance. And on the next part will be polymorphism and maybe interfaces. But for this video, we'll be talking particularly of inheritance. So objectives, at the end of the lesson or this video, the student should be able to define superclasses and subclasses and override methods of superclasses, and also create final methods and final classes. So this will be the objectives of this video. Inheritance. In Java, all classes, including the classes that make up the Java API, are subclass from the object superclass. A sample class hierarchy is shown below. So we have the object, and then from object we have a subclass that is class A and class D maybe, and then under class A maybe class B and class C. A superclass is actually any class above the specific class in the class hierarchy. So in this example, class A is the superclass of class B, and also class A is a superclass of class C. At the same time, object is the superclass of class A, and also object is the superclass of class D. Subclass is any class below the specific class in the class hierarchy. So class A is a subclass of object, and class D is also a subclass of object, while class B is a subclass of class A, and class C is also a subclass of class A. Inheritance. Superclass is any class above the specific class in the class hierarchy, and subclass also, I just repeated that, below the specific class in the class hierarchy. We discussed that a while ago. So inheritance, what is the benefit of inheritance in OOP? So the main benefit is reusability. Once a behavior or method is defined in a superclass, that behavior is automatically inherited by all subclasses. Thus, you can encode a method only once, and they can be used by all subclasses. A subclass only needs to implement the differences between itself and the parent. So whatever is the differences, that is only be implemented in the subclass. So no need to recode whatever is on the superclass. That's why reusability is one of the benefits. So to derive a class, we use the extends keyword, so extends. In order to illustrate this, let's create a sample parent class. Suppose we have a parent class called person. So we have a person, protected string name, protected string address, etc. And then public person, so system.out, print and print line inside person constructor, name equals, and then address equals to blank. Now we want to create another class named student. So we have a person class, then we want to create a class named student. Since a student is also a person, we decided to just extend the class person so that we can inherit all the properties and methods of the existing class person. So to do this, we just write the following. So public class is student, and then we add extends person. So person is another class. So in the constructor, public student, so a system that out inside student constructor. So just to for us to determine or to monitor what constructor is being executed. So if this is executed, it will place it inside the person constructor, while here it will display inside student constructor. So when a student object is instantiated, the default constructor of its superclass is invoked implicitly to do the necessary initializations. After that, the statements inside the subclass constructor are executed. So again, once we instantiate the student object, it will first execute the constructor of the superclass implicitly. So we don't need to specify that, but it will automatically be done. So after the constructor of the superclass is executed, and then it will be the statements inside the subclass constructor that will be executed. To illustrate this, consider the following code. So student Anna equals new student. So you notice in our class, if we're going back, we have here, it will first inside person. So since this is a superclass, it will first execute this and then it will execute this one. So next will be inside student constructor. That's why the output for this, if we run this program, will be inside person constructor, then inside student constructor. So it will first execute the superclass constructor before the subclass constructor. So the program flow is shown below. So we have the class person, then we have the student constructor. So this one extends the person class. So once we create the object, it will first execute this constructor. So yeah, so if we execute, it will call this one, but this one will first call the superclass. And after the superclass, and then it will execute the next statement in the constructor, and then it displays here the results. The super keyword. A subclass can also be explicitly call a constructor of its immediate superclass. This is done by using the super constructor. A super constructor call in the constructor of a subclass. A super constructor call in the constructor of a subclass will result in the execution of relevant constructor from the superclass based on the arguments passed. So since there's overloading, so it will be based on the arguments passed. So the super keyword, for example, given our previous example, classes person and student, we show an example of a super constructor call. So again, person is our superclass. So public student and then super, some name, some address. So this is actually coming from the person class. So this is being called from the constructor of the person class. Then after this is done, then system that out the print line inside student constructor. So here are a few things to remember when using the super constructor call. Excuse me. So the super call must occur at the first statement in a constructor. So remember that it must occur at the first statement in a constructor. The super call can only be used in a constructor definition. So this implies that the this construct and the super calls cannot both occur in the same constructor because both of them should be be used as the first statement of a constructor. So you should only be using one. Another use of the super is to refer to members of the superclass, just like the this reference. So the this is for the current class, while super is for the superclass. So let's say, for example, public student. So super.name is referring to the person class. So is equal to some name, and super.address is equal to some address. Overriding methods. If for some reason, let's say a derived class needs to have a different implementation of a certain method from that of a superclass, overriding methods could prove to be very useful. A subclass can override a method defined in its superclass by providing a new implementation for that method. So this is what that means. Example, suppose we have the following implementation for the getName method in a person class. So we have a getName method in the person superclass. So it says here it will print parent and then getName, return name. Now we actually inherited the person class to the student, but you notice here it says here it will display parent, but this is now a student. So we can create a method with the same name, getName, that will print student and then getName, return name. So in that case, the getName of this superclass is actually overridden. So we already have override overridden this method. So when we invoke getName method of an object of subclass student, the overridden getName method would be called, and the output would be student getName. So the previous getName will just be ignored. Final classes. Final classes, so classes that cannot be extended. So it cannot be anymore inherited. So to declare final classes, we just write public, final, and then class name. So we just add the keyword final. So for example, public final class person. So other examples of final classes are your wrapper classes and also strings. So these are final classes. So we could not inherit, or we could not create a class that inherits these classes. So the final methods in class is a final method. So methods that cannot be overridden, these are final methods. So to declare final methods, we write public final, then the return type method name. So if we use the final keyword, then that means that we could not override these methods. So static methods are automatically final. So static methods, we don't need to say final because they are automatically final. So example, public final string get name. Okay, so that ends the first part of this video. So we have talked about inheritance, superclasses, subclasses, the super keyword, the final keyword also for methods that cannot be anymore overridden. Okay, so thank you very much for viewing this video.